Welcome back to the second video. Let's go ahead and finish number 11. We are verifying this equality here, and we now have negative sine squared over cosine squared. And you could look at that and say, well, Ms. Reams, let's just stop and say that's a negative tangent squared. And I fully agree, that is negative tangent squared. However, that's not the equality you're trying to prove here. So you need to look over at what you're trying to prove. You're trying to prove that this negative tangent squared is equal to cosine squared minus 1 over cosine squared. So what we need to do is manipulate this a little bit so that we can get to that form. Now the cosine squared in the denominator were already established. But I need to rewrite the sine squared, negative sine squared theta as cosine squared minus 1. You can't just make that jump right away. You have to show me that sine squared is equal to 1 minus cosine squared. So we're going to make that substitution right now. And we're going to say negative, instead of negative sine squared, we're going to say negative 1 minus cosine squared. Show me that you're making that substitution with that Pythagorean identity. We're going to leave the denominator the way it is. And then you can show me that that negative is going to distribute to both terms. And then you will have a negative cosine squared. So then you have positive cosine squared theta. You will have a negative 1 over your cosine squared. That's what you wanted to prove. Okay? I know that the tendency up here is just to stop and say negative tangent squared. And you could have simplified this left side to that. I understand. But in verifying this equality, you need to continue and keep going. All right, let's do one more. Number 13. Number 13 says tangent squared over cosecant x minus 1 is equal to tangent to the 4th times cosecant minus 1. Now, a couple things to notice. One, some people are going to always go, or at least try to start from the left and go to the right. Some are going to want to go from the right to the left. You can probably do it both ways. I'm looking at this, seeing, all right, I've got one squared term, tangent squared, which I know can get me to secant squared. All right, secant squared is not going to help me much with the cosecant, but if this right here were squared such that I could have a cosecant squared minus 1, right? I can subtract that 1 over here and get cosecant squared minus 1. That would equal cotangent squared. Oh, and that plays very nicely with a tangent. So you are going to use the conjugate on this one. If you multiply by the conjugate of the denominator, and sometimes it's the numerator on some problems, but this time it's the denominator, then I can make the denominator go to the cosecant squared minus 1. Let me show you. So first we have the tangent squared. I'm leaving that alone. And we have cosecant x plus 1. But we're going to multiply by the conjugate of the denominator, which is cosecant minus 1. And again, that is simply 1. It's the same thing over itself, so it's not changing the value, just its form. So my numerator, now the tendency is to distribute this, right? Well, don't bother, because look over at the right side. You see how it kept the tangent outside to begin with. And this is already what we want. So I'm going to leave that numerator the way it is. I am not going to distribute it. Now my denominator, however, I am going to distribute those, FOIL that, and I see that I get cosecant x squared, or squared, minus 1. And I know that cosecant squared x minus 1, remember, over here, cosecant squared x minus 1, if you bring that 1 over, is equal to cotangent squared. So, if that is equal to cotangent squared, okay, now look at what I need. I need to remember that if I have a cotangent in the denominator, that's the same thing as tangent. And if that cotangent is squared, it's equal to tangent squared. So, this lovely cotangent squared in the denominator can be rewritten as tangent squared times all of this cosecant x minus 1, right? That cotangent squared in the denominator can be written as tangent squared. That went here, okay? And I no longer have a fraction. But now I also have 3 terms that are just multiplied together. I can take the tangent squared times the tangent squared and make that tangent to the 4th times that cosecant x minus 1. And that is exactly what we wanted. Yay! Ta-da! Okay, so I think you'll enjoy the verifies. They are a little bit easier. They're just huge puzzles. A lot of us that teach this love this section. So I hope you enjoy it a little bit more. I hope they're getting easier. They definitely get easier as you become more familiar with your identities. I will see you in class when we will finish this worksheet, and then the next lesson is a review, and then we will have a unit quiz over all the simplifying and verifying. I will see you then.